Okay, let's get started. Let me turn on my camera so that everybody can see me. Hello there. So I'm Maxim de Witte, Business Development Manager at Unitron. So good afternoon or maybe good evening to some of you. So thank you for joining this webinar where we will talk about our fiber optical distribution solution. So we will have different topics we will discuss. The first topic will be the fiber fundamentals. For the people who are already familiar with fiber, maybe it will not be anything new there, but especially for the people who are not so familiar, could be interesting to be attentive during this first part. The second part will talk about our products, the different product ranges we have, and then I will give you a demonstration of our optical configuration tool, which we made. I will give a live demo of that as well. And at the end, we will have a Q&A session in case you have any questions you would like to ask. So let's start. Let me turn off my camera. Okay, so before we start, maybe a few house rules. So all the microphones are muted except mine, of course, and there will also be a possibility to ask questions at the end. So you have the question pane here and the GoToWebinar tool. So you can just ask your questions and we will answer them at the end of the webinar during the Q&A session. So our fiber optical solution. So these are the three parts we will cover today. We will start with introduction and fundamentals. So this is the real fundamental of optical distribution. So you always have a transmitter and a receiver. So the transmitter will basically convert the electrical signal, in our case coming from the coax cable. It will convert this electrical signal into light using a laser or an LED. And then this light will travel over an optical fiber cable to the other end, to the receiver, which contains a photodiode, and this photodiode will capture the light and convert it back into an electrical signal. So basically that's the real basic fundamental of fiber distribution. The main advantage is of course the distance you can cover. As you know, with fiber there's almost no cable losses, so you can cover huge distances. Also the bandwidth can be a huge advantage. So for the people who are familiar with RF, radio frequency technology, there are quite some similarities with optical. First of all, we also talk about dBs, but in optical we use 10 log dBs and not 20 log. Maybe already quite technical, but basically what does it mean? If you have an optical a 3 dB loss, this means that the fiber signal, which is in the optical signal, this means that for RF, you will have a 6 dB loss. So double the dB loss as of optical. So we also talk about noise when the signal is too low, or distortion when the signal is too high. This gives you a dynamic range. I will talk about that a bit more in detail in the next coming slides. And from a product point of view, we also have splitters, amplifiers, so all similar kind of products we use in RF. But difference is, of course, we don't talk in megahertz in optical, we talk in nanometers. But the similarity here is that you can have different wavelengths on the same cable, similar like you can have different frequencies on the same coax cable. But in optical, we talk about wavelengths in nanometers, 1310, 1330, for instance. And in RF technology, for instance, you have the 474, 482 megahertz channel. So all this is also on the same cable. So that's also similar for optical. There are, of course, some differences. The one I already mentioned is with optical, you don't have, or you almost have no cable losses, with the main advantage that you can cover huge distances without having to amplify your signal. Another advantage is that the return loss is not an issue in fiber. It's typically 60 dB, so nearly no return loss. Another advantage is you cannot have grounding loops. This means that grounding current would run through your cables in case of coaxial cables. This is of course not possible with optical cables because they cannot conduct electricity. But that's also a disadvantage, of course. This means that we cannot use the cable for DC powering, something that is commonly done with coaxial cables. So we use the cable to power the LMB, for instance. So this is not possible with optical. And another difference is that in optical, the dynamic range is limited than in coax. And this is an important topic, which I will discuss a bit more in the next slides. So what is dynamic range? This is basically the difference or the delta between your weakest and your strongest optical signal in your system. So this is a nice representation of that. So this is the highest. So this is the limit, the upper limit, the 9 dBm. So basically, this is the output level of which comes out of our fiber transmitter, and the lowest level is minus 14, minus 15 dBm. So this is the lowest level we can go, and the difference between two. This is your dynamic range. So what does it mean? Your optical signal should always be within these two limits. If you go beyond if you pass the highest level, then you get distortion. Or if the signal is too weak, too low, then you will end up in the noise, and it also will affect your signal quality. So that is of mandatory importance that your optical signal stays within these two boundaries. So I will show you what the effect can be. So imagine that you have a not so perfect RF signal. I think for the people who are familiar with RF, this looks very familiar. So you have between different transponders or multiplexes, you can have a signal strength, signal level difference, and especially towards the end that you have a roll-off, because as most of you know, the higher the frequency, the more cable loss you have. So this means that for the transponders in the higher frequencies, you have more signal loss towards the end. If you then, of course, take such a RF signal and you put it in the fiber transmitter, so imagine that you already have a 6 dB difference between the highest transponder and in the middle, and then on the right the lowest transponder. So you have already 6 dB difference. This means optical that you already lose 3 dB. So the highest transponders will be here close to 9 dBm, can also not go any higher, otherwise you get distortion on the highest transponders. So you have to stay below the 9 dBm. Of course, because of this difference between these two transponders, the weakest transponder will already start at a lower level. And of course, if you then start splitting the signal using passive optical splitters, the signal will always go down. Every time you add a splitter, the signal strength is going down. And at the end, if you do too many splits, the result will be that your weakest transponders will end up in the noise. And this results in a loss. So you lose the weakest transponders. Or maybe you will not lose them, but definitely you will have distortion in your video image. With the result that in this case you cannot do 128 splits, which you maybe had in mind to do for your project. So you can only do 16 or probably 32 splits in this case. Of course, to solve this means that you have to add an expensive amplifier, or that you have to add an additional fiber transmitter and split your network in two. So that can be a disadvantage. On the other side, if you can start from a perfect RF signal like this, all the transponders are equally aligned. This will make a big difference if you start from such a signal. This means that all the transponders will be very close to the 9 dBm. So all the transponders will have almost the maximum. And you can then, of course, imagine if we start splitting from this type of signal, that after 128 splits, all your transponders are still above the noise, giving you a perfect RF signal at the output of the optical receiver. So in this case, we are able to do 128 passive splits from a single transmitter. So it is of a mandatory importance, of course, to stay within the dynamic range, but also to help with that is that your RF signal should be perfectly aligned before you enter it in the optical transmitter. And for that, we have a few products and accessories you can use for that, which I will show in the next coming slides. So our solution basically makes optimal use of the dynamic range. First of all, we use a high power output of our optical transmitter, plus 9 dBm. So, and this already then gives you 24 dB dynamic range. But more important is, compared to some of the competitors, we don't do any RF stacking. So we use different wavelengths on the same cable. So if you have only one wavelength, this means that you have to put all the RF signal on the same in the same wavelength. This means that you have to put all the RF signal on top of each other, going to 5-6 gigahertz. So we don't do this. So we use different wavelengths. So in total 3. So and we split the RF signal, or we divide the RF signal over these 3 wavelengths. So typically we use one wavelength for the vertical transponders, one wavelength for the horizontal transponders, and one wavelength for the terrestrial channels. And this combined with our products to align the RF signal. So we have different products for terrestrial and satellite. So all this results in more the possibility to do more optical splits. So as mentioned before, so we use different wavelengths. So for terrestrial, typically we use the 1550 nanometer wavelength. And then for satellite, for instance, the vertical transponders or the horizontal transponders, we use 1330, and the vertical transponders, we use 1310. So all this goes into the transmitter. And because we use different wavelengths, we have to, of course, put these different wavelengths on the same optical cable. For that, there is always a WDM in our transmitters to combine the different wavelengths. And on the other side, so at the receiver side, we also have a DWM, which does the opposite. It takes apart again the 3 different wavelengths, so that, of course, at the output of your receiver, you have your original input signal again. So this is how our solution works. So as I mentioned before, it's of mandatory importance that before you distribute your RF signal, is that it is perfectly aligned. And for that, we have different products. For instance, for the terrestrial, we have our profiler range. People who are familiar with this product range knows that we have a long history in this kind of product. So basically, this product will turn a terrestrial signal like this into something like that. So it will treat every individual multiplex, and it will make sure that all the multiplexes are equally aligned. So, and that's then a perfect signal to go into your fiber transmitter. The same we have for satellite. So for satellite, if you have, this is not such a bad signal. So most transponders are already perfectly aligned, except of course towards the end, you have the typical roll-off because of the higher frequencies. In that case, you can use our 9657 trunk amplifier. This is an AGC ASC, so automatic gain control, automatic slope control. So basically, this device will turn this signal again into a perfectly aligned signal. And again, it's a perfect signal to go into your transmitters. If you have a satellite signal which is not that good, maybe coming from different satellites, different LMBs, then we recommend to use the 9780 unit. We call it a compact satellite converter, because this one will, similar to the terrestrial unit, this one will treat every transponder individually, turn it again into a perfectly aligned satellite signal. So these are different products we recommend to use in your system, because it's, as I said before, of mandatory importance to have a perfectly aligned RF signal before you start your optical distribution. If you do this, then your installation will be much more easy and also stable towards this future, because all these units have active gain and active slope control. So even if the dish is moving or you have bad weather, these units will always try to adjust the signal to have a perfect signal. So in this slide, you can see the results. So these are the test results we have with our solution, and in this case we used a 4013 optical receiver, so this model with the 3 outputs. So on the left we show you the results of the MER, so the signal quality. So on the y-axis here, on the in the vertical position, you have the MER level, and in the horizontal position, the x-axis, you have the number of splits. So 1, 2, 4, 8, 16, all the way up to 256. On the right side, we have the signal level in dB microvolt. So again, the bottom is the number of splits, and the y-axis is the signal strength. So if we look at the MER, so we start at a quite perfect signal. You always have to start from a perfect signal, of course, or as perfect as possible. So in this case, it's 14, almost 15 dB, which is really perfect. So what you see as you have more and more splits, basically the MER stays the same. Only at 32 splits, you see that it's slightly going down. Even at 64 splits, it only went down with a half a dB, which is nearly nothing. And even at 128 splits, the MER only dropped 1.5 dB. So still giving you 13 dB MER, which is still more than perfect. So even at 256 splits, passive splits, we still end up with a MER of 9, which is probably too low. But maybe in certain cases, your video image will still be perfect, depending on the number of transponders and the modulation which is used. But okay, definitely you can do 128 splits with our solution without any signal degradation. So then if you look at the right side, our signal strength and dB microvolt, so we start around 93 dB microvolt, and of course, logically, every time you split, the signal level goes down. Typically, it will go down a more or less straight line. But in our case, you see that around the fourth split, it's equalizing, and this is because of the automatic gain control, which is also built in this receiver and even in all our receivers. So all our receivers have automatic gain control, which is set at around 80 dB microvolts. So here what you see is that from 4 splits onwards, the signal level would drop below the 80 dB microvolts. And this is where the AGC kicks in. So it keeps the level straight around 80 dB microvolts. Only at 32 or 64, you see a slight drop, but still at 64, we are close to 80 dB or 79, which is still perfect. Also 128 splits gives you 73 dB microvolt, which is still okay. 256 splits give you around 69, 68 dB microvolt, which is just on the limit. But also here again, 128 passive splits is still doable. In the next coming slides, I will talk a bit about the cabling. Fiber cabling is of course different as a coax cable. So this is the inside of a cable. So basically this is more or less 2 millimeters. So the core, this is basically where the light is traveling through. It's very, very small. That's only 9 micrometers. Just to give you an idea, so the core is 9 micrometers and the cladding around it, which is also important, is 125 nanometers. So this is the type of cable that should be used with our solution. But 125 micrometers, basically that's the thickness of a human hair. So you can imagine how small the core is of a fiber cable. That's why you're not allowed to bend a fiber cable too much, otherwise you will damage the core. So when the core and the cladding is most important, all the rest is basically reinforcement to protect the core. So this is how the inside of a fiber cable looks like. So which fiber should be used with our solution? Basically, it's a single mode fiber. So we use the 925 micrometers cable with the core and the cladding. It's a simplex cable, so only one cable, and we use SC APC connectors. So this is the type of cable you have to use with our solution. A bit more about the connectors. So we use SC APC connectors. SC stands for standard connector or subscriber connector. There are different names for it, but more important is the APC, which stands for angle polished physical contact. What does it mean? It means that the tip or the end of the optical cable is under an 8-degree angle. And the main advantage there is that you have good or no return loss. The best optical return loss, basically any light that would reflect, is reflected under an angle, so it's not reflected in the upcoming or incoming light beam. So that's the main advantage of an angled connector. But also it's much more robust for multiple reconnections, which can also be important. It's a green connector, of course everybody can see that, but the color green has a meaning. This means that it's an APC connector, so it's also our plugs or optical connectors in our products are the same color, so you just have to make sure that it matches the same color. And the last thing I want to mention, and it's maybe most important in optical solutions, it is of utmost importance that your cables are clean. So you keep them clean, make sure they don't become dirty, because this is the cladding, this is the core of an optical cable. So this is the 9 micrometers you see, and this is the cladding. So this is how a clean cable looks like. And basically this will transmit or let 100% of the light through. Of course, if you have dust particles on your cable, like here, you see already some dust particles. If these dust particles are on the core, then it will block the light. Any light that is stopped by these particles will not be detected. So you can lose, for instance, 25% of your light strength by just a small piece of dust which is on your optical cable, and this will result in the signal quality loss. But even worse is you have oil, like if you touch the connector with your finger, it will always leave some oil. If you are really rough and you damage the connector, so you can have pits, this will all block or deteriorate your optical signal, and even you can lose 50% of your signal. So that's really a shame. If you buy good quality products and you do a very good neat installation with very high quality cables, but it is all a bit pointless if your cables are dirty. So basically in this case it's same like putting an attenuator in your network. So basically it's the same if you touch the cable with your fingers. So this is something that I want to stress, that you always keep your cables clean. It will make your life much more easy, and you will be able to reach the number of splits you have in mind. If your cable is dirty, you can always use special tools to clean it. There are many tools for that to do it. So it's recommended to keep your cables clean. So this brings us to the end of part 1. I hope it was already interesting. So we will continue to part 2, where I will talk about our different products. So how does it work? Maybe first I will start with our LMB. maybe you already noticed that we use one wavelength for all the vertical transponders. And this is because we don't use a quad-core LNB, we use a wideband LNB. And people who are not familiar with wideband LNB, it's more or less the same as the quad-core LNB, but the main difference is that you only have 2 cables coming out instead of 4. So with a quad-core LNB, you have the typical 4 quadrants, the vertical low, vertical high, the horizontal low, and the horizontal high. So this we don't have with the wideband LNB because we combine the low and the high frequencies on the same cable. So this means that we have only one cable containing all the vertical transponders, and we have another cable which contains all the horizontal transponders. Of course, the frequency range is then bigger, doubles the size. Instead of 950 to 2150, in wideband it starts at 290 all the way up to 2340. But the main advantage is that you only need 2 cables per LNB, so only 2 trunk cables instead of 4. Then we have the fiber transmitters. So this will convert the electrical signal into optical. So this model has 2 inputs. And then of course we have 2 wavelengths, 2 optical or 2 wavelengths as output. The input is ultra wideband, I would call it, because it already starts at 5 megahertz. So the input range of the RF inputs is from 5 to 2400 megahertz. So this means that you can use our optical solution for different applications. You can use it for satellites, you can use it for terrestrial, even you can use it for cable. As long as the frequency range which is entered is within this range, then it's okay. Of course, keep in mind for cable, there is no return path, so it's only one-way direction. So you can only use it for cable TV and not for internet or so. On the other side, we have the receiver. Basically, this is the opposite of the transmitter. So here, the input is the optical signal and the output is the RF signal. It means whatever you put in here, it will come out here unchanged. So if you connect a wideband LNB, then this means on these 2 outputs, you will have all the vertical transponders coming out and here all the horizontal transponders. Again, the frequency range is from 5 to 2400 megahertz, same as the transmitter. We also have another type of optical receiver, which is, we call it a fiber termination unit. What is the main difference? Here, the signal which comes out of the RF output is not the same anymore as the signal which went in. So imagine that you have a wideband LNB. So this unit will convert the wideband signal back to the 4 quadrants like in a quad-core LNB. It will convert the signal again to 950 to 2150 megahertz. And this is of course necessary because most decoders or set-top boxes, they don't support wideband yet. They still expect a signal within this frequency range. So this unit will convert the frequencies to the, I call it the traditional frequencies. So 950 to 2150. So this means that you can connect your set-top box or decoder directly to this output, or you can also use it to feed the output of this unit into a multi-switch. But I will come back to that in the next coming slides. So an overview of our fiber products. So the transmitter, so this one I already explained a bit. So this is the 4000 optical head-end transmitter, whatever you want to call it. Basically, it has 2 inputs, 2 RF inputs, typically used for a wideband LNB, and it has 1 optical output, which gives 9 dBm of signal strength. 2 wavelengths are used. For each input is a unique wavelength, so 1310 and 1330 nanometers. So we have a second optical head-end or transmitter, which is the 4001. What is the difference? It only has a single input. The wavelength is different, it's 1550. It also has optical outputs, but it also has an optical input. And the optical input is used to combine it with the 4000 unit. So the signal the optical signal coming from the 4000 unit, you can enter into the 4001 optical headend, and then in this headend, basically the terrestrial channels will be added together with the satellite channels, and this will be then multiplexed on a single cable. So then the output of the 4001 unit is going to your fiber network. So these are the two transmitters we have in our product range. On the other side, the receivers. So we have the 4011. This is a single optical input, only one wavelength. Does it support the 1550, and that it has a single RF output. So it's wideband or ultra wideband from 5 to 2400 megahertz. And as I mentioned before, all our optical receivers have automatic gain control, so which is set at 80 dB microvolts. So from there, you can continue, for instance, the distribution using a single coax network. Another model is the 4012. Okay, this 2 stands for 2 outputs, but of course a single optical input, but 2 wavelengths, 1310, 1330, 2 outputs, and again automatic gain control. For instance, this one can be used to be connected to wideband compatible devices, such as some decoders are already compatible. The latest decoders are already compatible with wideband. In this case, you can see here a Sky Q box for the people who are familiar with Sky. So their latest decoder, you can directly feed a wideband signal directly to the decoder. I know there are many people from Africa joining this webinar. Also, the new SAT-IP server from MultiChoice or DSTV is also wideband compatible. So you can also feed in the wideband signal directly into the DSTV SAT-IP server. And the last optical receiver we have is the 4013. And of course, the 3 stands for 3 outputs and also 3 wavelengths, 1310, 1313, 1550. Same frequency range, again, AGC control. And this model is mainly used in a hybrid system where we have an optical receiver having satellite signal on 2 outputs, vertical and horizontal, and then terrestrial channels on a 3rd output. And this you can then feed in, for instance, in a wideband compatible multi-switch. And then you can continue your distribution over multi-switches. Then the other optical receiver type we have is the fiber termination unit. So here we have 2 models, the 4031, single optical input. It supports all wavelengths, all 3 wavelengths. This one has 2 outputs, or better 3 outputs. So 2 generic outputs which contain the satellite and the terrestrial, and a terrestrial only output. So the 2 generic outputs, so these contain the signals all the signals coming from the different wavelengths. So it will have a satellite and terrestrial combined. And here it means, as I mentioned before, these units will convert the wideband signal into the traditional quattro signal. So here the output will be 950 by 2150. So this means that you can connect your set-top box or decoder directly to this output. And it's also SCR compatible or unicable, as some call it. So this means that you can also connect multiple SCR compatible set-top boxes on the same output, similar to the SCR multi-switches we have. Then the second model is the 4032, but this one is a bit special. There's a small switch here in the top right. So this model you can set to quad SCR mode or to quattro mode. In the quad SCR mode, basically it's the same as the 4031, but the main difference is that you have 4 outputs. So 4 generic outputs instead of 2. So this means here you can connect up to 4 traditional or legacy set-top boxes or multiple SCR set-top boxes to a single output. So basically this one you can install directly, or both you can install directly in the apartment or the house. And from there you distribute your coax cables to the different rooms. Or if you have SCR compatible decoders, then you could also install this into the trunk and just put one coax cable to one apartment, and there's use a standard splitter or a smart splitter to split to the different rooms. Basically, this unit, as it is in this mode, you can look at it as an optical receiver combined with a four-way multi-switch all in one. And then the second mode is the quattro mode. Basically, you turn the switch to quattro. And what is the difference? Then every output will be fixed to one of the four quadrants. So you have vertical low, horizontal low, vertical high, horizontal high on the four outputs, and terrestrial. And then you can feed this into a traditional or legacy multi-switch system, which expects the four quadrants and terrestrial. So in the next slides, I will give a quick overview of the accessories. I will not go into much detail. So these ones I already explained a bit. So these are the products that you can use to equalize and amplify your RF signal. So we have two models, and typically we use one of these two models in a fiber solution for terrestrial TV, and for satellite we have these two models. So basically, they will filter, equalize, amplify your incoming RF signal so that you can have a perfectly aligned signal at the output, and that's then perfect to enter into your optical transmitters. So we also have a number of wideband distribution accessories. Of course, the LNB, which I already explained. We have a line amplifier. We have a trunk amplifier. This is basically more or less the same as this one, but the main difference is that this one is not with AGC or automatic gain control and slope control. Here you have to adjust it manually. And then we have two-way splitters, two-way taps, and we also have a wideband to quad-core converter, just for your information. We will also offer optical accessories like splitters, cable, and attenuators. We offer this. It's nothing special, the typical splitters and cables you will find in the market, but you can also buy them from us. If you have a project, then we can offer you all the products you need for your project. Now in the next coming slides, I will show you some use cases. It's not only limited to these use cases, but these are the typical use cases which we see in the field. So the first one I will explain is the hybrid solution. So basically here we will combine fiber distribution with the multi-switches. So for that you have the transmitter and your receiver, in this case the 4032. This is in case your multi-switches or legacy multi-switches or traditional multi-switch, which expect the four quadrants at the input. And for that you use the 4032 in quad-core mode. If, for instance, you have a multi-switch which is wideband compatible, so our latest multi-switches are all wideband compatible, this means that you can use the 4012 instead of the 4032. So here the output will be the signal coming from the wideband LNB, and this you can then feed into a wideband compatible multi-switch. And from there you can continue your distribution using multi-switches. So the next example is the fiber to the home solution. So here you can, instead of using multi-switches, you can directly install the fiber termination unit in the apartment or into the houses. So this means that you go with your fiber cable all the way to the house, and there you convert it into electrical or coax. So these are two units you can install depending on the number of outputs you need. So that's a second solution you can have. The third one is the wideband solution. Basically here we will distribute, this is in case you have wideband compatible receivers. So for instance, the SkyQ box or the DSTV SAT-IP server. So you have a wideband LNB. Okay, you amplify it, transmitter, splitters, and then you use the 4012 receivers, which will output again the wideband signal, and this you can then directly feed into your wideband compatible set-top box. So that's a fourth example which you can use with our solution. The next one is a single coax cable solution, because now there are many products where you can do channels stacking. This means that you take a number of transponder and multiplexes and you just stack them next to each other on a single cable. So for instance, you can use a digital LNB or a DSCS LNB or unicable LNB. Basically, it's all the same. And here you select the number of transponders, put it on the cable, then the cable goes into, in this case, the profiler evolution set, because this one has a satellite input, and then you can just add your terrestrial multiplexes, and basically the satellite and the terrestrial channels are all on the same coax cable. And this you can feed into the 4001 optical headend, which then will be distributed to your optical receivers, and from your optical receivers you can basically continue your distribution over coax. So that's a fourth use case we want to present. And the last one is in case you have huge projects way beyond the 128 splits. It's also possible with our products. So even we can go up to 2000 splits, and I think even more already. So in that case, how do we do this? And we don't use expensive optical amplifiers. So basically what we do, you have your terrestrial, your satellite, okay, your amplifiers. Okay, maybe important, you can see here two compact satellite converters. So for one cable, you need to have one of these devices. The bandwidth of the unit is just enough to handle the frequencies or the transponders coming from a single polarity. So for each polarity, you need a second unit. So for huge installations, we recommend to use this product, because these gives you the best output independent of what basically the signal quality is at the input. So what do we do for huge projects? So you have your transmitters, your two transmitters, and then your first layer, you split the signal, and then you go to your receivers. But here, instead of going to, for instance, multi-switches or directly to the decoders, we just add an additional layer of transmitters. So basically the output of the first receiver goes into the input, is going to the input of the next layer of transmitters. And this way you can have support huge installations up to 2000 and more passive splits. So this brings us to the end of part 2. In the next part, we will talk, or I will demonstrate, our optical configurator tool. It's a very useful tool we made to design your optical solutions projects. So if you browse to this website, www.ucloudserver.com, then you will be able to log in into our uCloud server platform. If you've never done this before, you have to create a user account. It's free, so so you don't have to pay anything. So anybody can use it. So if you're logged in, then you can go to the optical configurator tool. And basically, it's a very visual tool where you can design your project. So here you have your canvas to work in, and on the left you have all our products. So you can just drag and drop whatever you need, the dishes, the antennas, the amplifiers, the transmitters, splitters, receivers, and so on. So it gives you a very nice representation of your product. But that's not the main part. More important is, once you finish your design, you can, in the top right, you will see a button Analyze. So basically, it will give you, on every level, you can get an estimation of the signal strength. So of course, in the beginning, you have to enter the signal strength and signal quality for your dish, LMB, and for your antenna. And then if you run the analysis, we will just calculate how much signal strength you will still have at the output. And this is quite accurate in real life. And the reason why we can do this is because as I mentioned before, all our products are equipped with active gain control. So basically, every time we know exactly more or less what signal quality and signal strength is coming out of the device. And this is a very useful tool to design your projects. So in this case, everything is perfect. So you see the green check mark. You can also have orange, which is not bad, but it's also not perfect. So you can optimize it. Or if it's really bad, you will see a red cross. And then if you have a red cross, then you have to change your design until you have everywhere green check marks. And once you've done this, then you can also export your drawing into a PDF, which can also be very useful in pre-sales if you want to add it to your offer to your customer, or even an after sales once you have to install the system. Then you can use this drawing, of course, when you go on site to do the installation. And last but not least, instead of calculating by yourself the number of products you need, we do it for you. So you can go to export order list. So if you press that, then you will get an Excel with all the products and the quantities. And this then you can use to ask for a quote, or you can place an order. So in case you want to order the products. So this will help you not to make any mistakes in the number of products you need. And as I mentioned before, if you never used this platform, then you can easily go to the uCloud server. You have here in the top left, new account. You just click the account, you fill in the fields, and you have to enter your mobile phone because we will send you an activation code. And with this code, you can then activate your account. And from then you are good to go. So now I will show you a live demo. So let's go to the uCloud server. Okay, here we go. So this is where you can create a new account. Of course, I already have an account. So I'll just log in. So for your information, we use this uCloud, this platform, for multiple products. So also our digital headends, you can monitor, control from a distance. You can configure your LMB, your compact satellite converter. But of course, what I want to demonstrate during this webinar is our optical configurator tool. So I selected that. So my list is normally, if you have already made some projects or designs, then you will see all your designs here. In my case, it's empty, so we will start from scratch. So it just gives you some general information. Let's say Unitron 123. This is the name of my project. The installation date, okay, I set it to today. The address, okay, Poperinge. This is, let's say this is our address in Belgium. And then we do next. And then we have to enter some project details, like is it only satellite, or is it also with terrestrial? So let's add terrestrial. Let's do 2 antennas. And then you have to select the receivers, the optical receivers, or the output devices, as they call it here. Wideband quad-co, twin, SCR, legacy, or quad. So let's say that we want to design a hybrid system which is wideband compatible. So we take the wideband receiver and number of devices. So we'll not make it too big, otherwise it will not be visible for you guys. So 32, and then you can enter some advanced settings like number of transponders, number of multiplexes, signal level for both satellite, terrestrial, and the MER. Let's increase the MER a bit to 14 for satellite. And then here you have buildings, basically these 2 buildings and 4 floor per building. Doesn't matter if it's not for a building, but this we will use to split, to define the correct splitters. So imagine I have 32 outputs here. Imagine I have 4 buildings, and each building has 8 floors. So basically this will give, and then I can say create diagram. So the good thing also is it will make the diagram for you automatically. So you don't have to drag it one by one. You can do it, but it's not necessary. So, and then it gives you can easily drag it. Let me put this in the center. So one dish, 2 antennas, it will automatically select the right amplifier for you, depending on the size of the project. So of course I have 2 transmitters, and then I have my splitters, so the 4-way and then 4 times an 8-way. And then I have my 32 optical receivers. So basically, if this is my project, everything is interconnected. I don't have to change anything. You can always change like the level or something like that, but normally if you've done it correctly in the beginning, then you can leave it like this. And then here in the top right, you have analysis. So then if I press this, then we will calculate the signal level and strength along the network. Probably it's a bit small. You have all these green check marks. If you go with your mouse over it, it will give you, in this case, the horizontal transponders, so 70 dB microvolts and 14 MER. And then every time you go to the next level, the next 77, of course, because it amplified it a bit, MER stays the same because I have no losses or no signal degradation until there. And you can continue through your network, and everywhere you can check what the estimated signal level and quality will be. Of course, the most important is what you will get at the output of your receiver. And there, as you see in my drawing, of course, I make a drawing where it's perfect. All the check marks are green, but still you can check what the signal level will be. So in this case, 77 and 13.5 MER, which is still more than perfect. So if you're satisfied with that, then you can export the diagram, and then it will create a PDF which you can use for your quotation to your customer, or you can save it in your project files. So this is very useful. And then last but not least, you can create an order list. So here you see all the products that you need. Of course, you can change it. For instance, a receiver, if you say I want to have some extra receivers as spare, you can just increase the amount or decrease the amount. You can add some splitters, you can add some cables. So you just increase the amount like this. Oops. Okay. So you can easily add additional products if necessary. And if this is done, then you can export it, and this will create an Excel sheet for you containing all the different items and also the quantities. So you see here the different products with the product number and then the quantities that you need. This is the description. And then there's a link to our website. If you want to have more technical details or information about the product, you can easily click on that. So you can use this to request a quote from your local partner, or depending from the country where you are, you can order from us, or you can use this to place an order, of course. So this brings us almost to the end of my webinar. So let me go back to my presentation. So this is the end of the goodbye. So everybody, thank you for joining. I hope it was very interesting. And as I mentioned, don't hesitate to contact us if you have any further questions or inquiries about our products.